So one last thing talking about covalent bonds, we actually have two different types of covalent bonds that we can have. And your book describes these. I suggest not reading your book. Your book is going to give some numerical values for how we classify these. And really for us in this class, we don't really care about the numerical values. We're just looking more at the general concepts. So we have two different types of bonds. The first one is called a nonpolar covalent bond. And our other bond is called a polar covalent bond. So basically we're looking at how well do two atoms share the electrons in a bond. Okay? If they share equally, that's where we have a nonpolar covalent bond. Okay? And essentially what we're looking at are these are two of the same element. Therefore, what they have is equal sharing. Can kind of think of this as a tug-of-war. If you have two twins on either side and they have equal strength, okay, if they're the same person, then they're going to be able to equally tug on the rope. So they have equal sharing of the electrons. For our polar covalent bonds, okay, these are bonds that are going to be between two different elements. Therefore, you have an unequal sharing. One element is going to, be better at the tug-of-war, getting the center of that bond closer to them. Now in chemistry, we give a specific term to this ability to share electrons. Okay, and your book goes through this. The term is called electronegativity. And this is the ability of an element to attract an electron towards it. So how well can it pull those electrons closer to itself? And this is what we can assess a value to. We can give a number to it. And that's what your book goes through, and I'm not really going to test too much on that. Basically, I'm looking if you have the same element in a bond, okay, you have equal sharing, you have a nonpolar covalent bond. If you have two different elements in a bond, then that's a polar covalent bond. Okay, because there's an unequal sharing. And basically what's happening there is in the polar covalent bond, you have different electronegativities. So you're going to have one atom that is stronger than the other one. It's going to be able to pull electrons more. And then over for our nonpolar covalent bond, these are going to have the same electronegativities. So just like we ended our ionic naming, let's go ahead and end our covalent naming with some examples. So basically I want you to fill out the table, or fill in the table. And in this case, since we have two different types of bonds, I also want you to fill out whether it's a nonpolar bond or a polar covalent bond. So again, pause the video, fill out the table, and then when you come back, I'll have the answers for you. All right, so we have PBr3, so we have phosphorus tribromide, carbon tetrachloride, so we have one carbon, and tetra means four, so we have four chlorides, so CCl4. Hydrogen is a diatomic, okay, so it is H2 for its formula. H2O, okay, can go by two different names. The first name, hopefully you know, is water. Okay, very, very common chemical that we're going to use lots and lots and lots and lots, especially in Chapter 10. So that's water. The technical name, the chemical name for water is dihydrogen monoxide. And I2 is going to be iodine. Okay, it does not have a di in the name, nor does it have the IDE ending, and that's because it is one of our diatomics. Now as far as polar versus nonpolar, I'm going to shift that over here. Ran out of room. Okay, phosphorus and tribromide, so we have bonds between the phosphorus and the bromines there. Okay, two different elements, so this will be a polar covalent bond. Between carbon and chlorine, okay, again, two different atoms, so those will contain polar covalent bonds. In hydrogen, we have two of the same atoms, so that will be a nonpolar covalent bond. In water, we have bonds between the hydrogen and the oxygen, two different elements, so that's polar covalent. And iodine, same molecule or same atom, so we have a non-polar covalent bond. Definitely practice going through your naming of your covalent compounds, okay, and identifying between nonpolar and polar covalent bonds. The next video will give an overview, kind of a comparison between ionic and covalent compounds. And the biggest struggle that students have with this naming is what happens when I don't tell you if it's ionic or if it's covalent. Okay, you have to first identify if it's ionic or covalent and then go through your naming strategies. Okay, so you want to get both concepts independently mastered before you throw them together, and really show that you understand naming compounds.